After watching this video lecture, students will be able to name acids and bases.
So we're going to go ahead and explore acids and their nomenclature. We're going to talk about acids in a lot more detail when we get to the acid and base unit. But we will encounter acids and bases as we progress through this particular unit. So we're going to need to understand and get familiar with the nomenclature associated with each. So binary acids are actually a type of acid that consists of two elements, hydrogen as well as usually one of the halogens, either fluorine, chlorine, bromine, or iodine. So you're going to be looking at something with a chemical structure with this setup here. So notice you have a hydrogen and then that halogen attached. Okay, and the way that we're going to name these species is first we're going to use the prefix hydro, and then part of the other atom, the non-hydrogen atom, and add a IC or ic suffix to that portion, and then acid. So HCl is going to be hydrochloric acid. Okay, now we learned earlier that this would be hydrogen monochloride. However, we don't actually ever call it that in our day-to-day chemistry comings and goings. So hydrochloric acid is how this would be referred to. So something like HI, okay, that would be hydroiodic acid. Okay, so that's the nomenclature procedures for your binary acids. You're looking for a hydrogen directly attached to one of your halogens. Oxyacids are a little bit more complicated. They usually are compounds that obviously have oxygen and hydrogen, but then there's usually some other nonmetal present. So what you'll notice in our example problems here is that you'll notice that each of these species look like one of your polyatomics. Okay, and if we analyzed how these acids would behave in water, you would see that ions would get placed in water, and you subsequently would have your nitrate and nitrite polyatomic. So what we're going to do here is we're going to look at the nomenclature for these species. Okay, so first of all, you're going to give part of the polyatomics name. Okay, so this is nitrite. Okay, so nitrite, so we're going to include the nite portion. And then we're going to either add an OUS or IC ending depending on what kind of polyatomic we have here. Okay, so if our polyatomic ends in ite, we're going to put the OUS ending. If it ends in ate, we're going to use the IC ending. So when we go ahead and we look at our examples here, okay, we have HNO2 and HNO3. Your HNO2, NO2 is nitrite. And so we're going to have the OUS ending here, and NO3, or your nitrate ion, is going to give the acid the ic ending here. Okay, and you'll see other ones like H2SO4, okay, so that's going to be sulfuric acid. H2SO3 would be sulfurous acid. And basically any setup where you see this hydrogen attached to one of your polyatomics like this, you're going to have your acids. So obviously nomenclature is important. Being able to understand how to get to that nomenclature is important, but we can also just do some memorization as well. Okay, so these are the common acids that you guys need to be familiar with. We have our some of our binary acids here in the early section, and then we quickly move into our oxyacids. Okay, so these are the acids that will be commonly expressed or show up and come up in your work and your problems. So make sure you're comfortable with them. Bases are another compound that we're going to be looking at when we get to the acid-base unit, but of course they show up in the reactions and such that we're going to be dealing with over the course of this unit. So basically strong bases are just going to be named just like the ionic compounds that they are. Okay, so hydroxide containing compounds are just going to follow the nomenclature procedures that we know for ionic compounds. So potassium hydroxide, barium hydroxide. If it was with a transition metal, obviously you'd have some sort of Roman numeral indicating the charge on that metal. So one other base that you guys need to memorize is NH3, okay, or ammonia. Not ammonium, but ammonia. This is one that will come up as well. We've already talked about it a little bit, but it is a base that's not an ionic compound, so go ahead and just work on memorizing that now. So now that we've talked about our acids and bases, on how to name them and what they're called, let's go ahead and approach formula writing.